AI has the potential to help humanity combat climate change. It can help develop materials that are lighter and stronger. Aircraft made of these more lightweight materials will consume less energy, which is excellent news as flying is the most carbon-intensive form of transportation. AI can detect and predict methane leaks from pipelines, increase the efficiency of smart grids and power plants, and monitor deforestation in real time. So there is a lot that AI can do to reduce carbon emissions in the atmosphere. Unfortunately, AI also comes with its own carbon footprint, and it is huge. When we think of AI ending humanity, we envision self-aware machines rising and taking control. But a more likely scenario could be that AI's growing carbon footprint will put our climate goals out of reach, and it will be our insatiable use of AI that dooms us and not the AI itself. Hi, my name is Jason Matthew, and in this video, we will explore the different sources of AI's carbon footprint and what can be done about it. This video is one of a 3-part series. Please see the links for the other videos in the video description below. To properly understand AI's contribution of carbon to the atmosphere, we need to look at the entire life cycle of AI systems. AI models require vast amounts of data for training. Significant computational power and energy consumption are needed to analyze and process this data. Training ChatGPT-3 required 1,287 megawatt hours of electricity. It resulted in carbon emissions of 552 metric tons of carbon, equivalent to driving 112 gasoline-powered cars for a year. Large-scale AI models, such as those used in natural language processing and image recognition, often require training on robust hardware infrastructure, including data centers equipped with tens of thousands of high-performance processors and graphics processing units, GPUs. These data centers consume substantial amount of electricity, which can contribute to carbon emissions if the electricity comes from non-renewable sources. AI systems rely on vast amounts of data for training and operation. As mentioned previously, these large data sets are collected, processed, and stored in data centers. Data centers run 24/7. And most derive their energy from fossil fuels. When we burn fossil fuels for energy, the carbon the fossil fuel contains is released as a greenhouse gas, carbon dioxide. The world data centers are responsible for about 2.5 to 3.7% of global greenhouse gas emissions. This is more than the emissions from the aviation industry, which is a major contributor to carbon in the atmosphere. Data centers generate large amounts of heat and must remain cool for the hardware to continue working. About 40% of the electricity data centers consume is used to power massive air conditioners. In 2022, global data center energy consumption was about 1 to 1.3% of global energy demands. This is expected to increase by 1.8% by 2030. And this estimate could be very conservative. As AI sophistication continues to progress at the rate it has been recently, there will be an exponential increase in processing and energy demands as a result. Once trained, AI models require computational resources to operate, make predictions, and process data in real time. The energy consumption of AI systems during inference, that is, the mode where the AI responds to queries, can vary depending on factors like the complexity of the model and the hardware it runs on. The operational stage will most likely demand more energy than the training phase. One reason is that training is done a few times to keep the AI models current and optimized. In contrast, during the inference stage, the AI models process data whenever a user queries, and the energy demands quickly adds up depending on the number of users on the AI model and the frequency of their use. ChatGPT had 100 million active users in different time zones after 2 months of its launch. Energy-efficient hardware and optimization techniques can help mitigate operational energy requirements. Producing AI-specific hardware components like GPUs and specialized chips involves energy-intensive manufacturing processes. Additionally, disposing of outdated or non-functional AI hardware can be difficult and expensive to recycle or dispose of safely. The e-waste generated can have potential environmental and health consequences if not properly managed. E-waste can contain toxic chemicals leading to pollution and other environmental damage. While AI can have a carbon footprint, efforts are being made to improve AI systems, energy efficiency, and sustainability. Combining AI technologies with a commitment to renewable energy and responsible practices can help mitigate the environmental impact and contribute to a more sustainable future. A multi-pronged approach is required to address AI's carbon footprint. Let's recap the major ways that AI contributes carbon to the atmosphere and discuss how we can use that information to make AI greener. Energy demands. The higher the demand, the greater the carbon emissions. Fuel source. Most AIs are powered by fossil fuels. Burning fossil fuels increase the carbon in the atmosphere. Training stage. The larger the data set, the larger the energy demands. Inference stage. The more active users and the higher the complexity of the AI model, the larger the energy demands. Data centers. The more the servers heat up, the more energy is required to cool them down. Most AIs are powered by fossil fuels. Burning fossil fuels increases the carbon in the atmosphere. Companies are taking steps to decrease their carbon footprint in this regard. Major tech companies like Microsoft and Google plan to run their data centers on carbon-free energy by 2030. More people are using large language models such as ChatGPT to do online searches rather than existing web searches relying on smaller AI models that can consume less energy. Microsoft and Google have integrated large language model AI technology into their search engines, which experts believe could increase the energy consumed by up to 5 times per search. Presently, the major tech companies are in an AI arms race to see who can develop the most complex, sophisticated AI models. As these models and their byproducts are used by the public, the AI carbon footprint will grow at an accelerated pace, threatening our global goals of decreasing the world's carbon emissions. Clifford Stein from Columbia University's Data Science Institute says that we are in the awe and wonder phase with AI, but we should eventually make pragmatic decisions on using this technology. An LLM AI is not required to answer every query. Smaller and more focused AI models can be used for simpler tasks. For example, a complex, highly sophisticated AI should deal with complex problems, such as discovering new antibiotics and developing ways to improve agriculture. The energy consumption is justified in those cases, but not if you use the same AI model to create a Frank Sinatra cover of Lil Jon's Get Low. Researchers like those working on the Baby LM Challenge project are working on creating smaller language models trained on a fraction of the size of the data that GPT was trained on. Smaller models will take less time and resources to train and thus consume less energy. While they may not be as sophisticated or able to handle very complex queries as their larger LLM counterparts, they will have a role. It is tempting to want to use AI for every problem, but considering its impact on the environment, we should consider whether an AI solution is appropriate or even if a technological solution is required. Responsible use of AI will help reduce its carbon footprint. The more the servers heat up, the more energy is required to cool them down. Creating hardware that is more efficient and specific to high processing demands of AI could decrease the amount of heat AI infrastructure produces. Data center servers run continuously and they run hot. They rely on air conditioning to remain operational. Companies are finding innovative ways to keep their servers cool. For instance, Microsoft has employed a multi-pronged strategy to make data centers more sustainable and efficient to build, operate, and maintain. Microsoft uses a two-phase immersion cooling system where the servers are submerged in a special liquid that boils 90 degrees Fahrenheit lower than the boiling point of water. Unlike water, this liquid does not damage electronic equipment. The fluid absorbs the heat energy from the servers and changes to a vapor. The vapor rises, condenses on the tank lid, and rains back on the immersed servers, creating a closed-loop cooling system. Heat transfers in liquid are more efficient than in air, and the two-phase immersion cooling can reduce power consumption for any given server by 5 to 15%. Microsoft's Project Natick is exploring the feasibility of underwater data centers powered by offshore renewable energy. The underwater data center is filled with dry nitrogen air, and the servers are cooled by the natural cooling of the ocean and fans powered by renewable energy. Due to the stable, inert environment and lack of humidity and oxygen in the data center or on the seafloor, the server's performance under the sea was far superior to the replica servers in a land data center. There are even plans to build data centers outside of the Earth's atmosphere. Lone Star intends to have data centers on the moon by the end of 2023. The data centers could benefit from an abundant supply of solar energy. They may be less susceptible to natural disasters and sabotage. Thales Alenia Space is leading a feasibility study to install data center stations in space powered by solar power. This project could help Europe achieve carbon neutrality by 2050. Companies need to be able to properly track how much electricity their AI systems are using and the resulting carbon emissions generated. A group of Stanford, Facebook, and McGill University researchers have developed a tracker to do that. And Microsoft's emission impact dashboard for Azure enables users to calculate their cloud's carbon footprint. In light of the pressing environmental challenges we are up against, it's crucial to recognize the significance of sustainable artificial intelligence. With the increasing popularity and usage of AI, we need to consider its environmental consequences and ensure we use it responsibly and sustainably. Addressing the sustainability issues associated with AI and exploring how it can benefit the environment is essential. By doing so, we can uncover the obstacles and possibilities of sustainable AI and gain valuable insights into developing AI systems that foster long-term sustainability and well-being for everyone. Please support the channel by liking the video and clicking on the subscribe button and notification bell. Until next time, stay curious.